Welcome back. It's been a while since I made a video. Well, at least on YouTube. I've actually made well over 100 videos elsewhere. Can't say where it was. But this is what I'm up to. I just got a Denrod 200 watt 12 volt heating element. Now I'd say that I'd never buy one of those things, but well, I really actually get the stuff for free, so I didn't buy it. But I've had to buy some 12 volt panels. I'm getting two 100 watt 12 volt panels, and I'm going to test this. This is a modified one. The panels are for a friend of mine. I'm getting him those for Christmas, but he won't get them till mid-January or so, you know. So it's not much of a Christmas present. But as you can see right now, I got this waveform. Now a 12 volt panel, look up here, let's see, where is it? Calculation. Anyways, a 12 volt 200 watt element is 0.76 ohms, and that's pretty low. You know, as I told people, a 12 volt element never matches a 12 volt panel. You need at least a 24 volt. But this is the waveform. It's 2.2 milliseconds at this current power level. 2.2 milliseconds long. Has an on time of 44 milliseconds, off time of 1.76 milliseconds. And that works out to be about 20% duty cycle. So you can see from the power supply, they specify these panels coming at about 20 volts, but yeah, 19 volts is close enough. And if you take 19 volts and divide it by 0.76, you're getting well over 25 amps. And that's being handled by two IRFB 4321s. I like that number. They're 104 amps, 9.3 milliohms. And I've been doing this for about an hour, and you can barely tell that these are warm. This board was never designed to do 25 amps, and basically the capacitors are only good for about 0.3 milliseconds of energy storage. So yeah, we're operating this way below capacitance levels. You know, that's why I like higher voltages, because you can use a smaller capacitance. So yeah, if we had a 24 volt element in there, it would be running much better. So yeah, that's it. And if we look at this, 19.3 volts divided by 25 amps times 25 amps is around 490 watts. Okay, 490 watts. If you figure a 20% duty cycle, that's 98 watts. From the power supply, we see it's 19.3 volts at 5.3 amps, 102 watts. So that figures out to be about 96% efficiency. I don't think that's quite the real number, but at least we're in the ballpark. And you know, the interesting thing is, if you had that 12 volt element, the two panels coming are 5 amps each. They're going to be in parallel, so that's you know, 10 amps at best. You hook that up to a 0.76 ohm panel, and across the element, the panel voltage will drop to 7.6 volts times 10 amps, 76 watts. So that's why they never match up. That's why you should never use a 12 volt element. I mean, you know, to everyone, a 12 volt 200 watt panel and a 12 volt 200 watt element sounds like a match made in heaven, but it's not. So like I said, this is modified. I don't have, because I have to run it a little bit faster. It's running at about, you know, 480 hertz or someplace like that, somewhere between 400 and 500. If we vary the voltage, so it's just turning on now, the on time stays the same because we're dumping power in, and it's dumping all the capacitors can store. So that on time, which is the low part, stays the same. And when we go up in higher power, the off time just changes a little bit. So that's why I prefer a timed reset rather than something like a TL494 with a set frequency. Then you get into narrow pulses. Narrow pulses, you know, you'll get a lot of FET heating, and you can't really control them good at the low levels. But this, we could, you know, it could extend out for a second, storing energy, and then just dump that. So that's it. We'll get you another one soon.